Hello, my name is Alexandra and I'm a researcher at the Usable Security Group of SBI Research. Today I have the honor to present to you our paper, User Mental Models of Cryptocurrency Systems, a Grounded Theory Approach. 1 decade after the first Bitcoin transaction was conducted, numerous cryptocurrencies entered the market and their usage increased. At the same time, various articles reported anecdotes of negative user experiences with the security and privacy of those digital payment systems. For example, in the end of 2017, this disturbing article appeared where a man threw away his hard drive with all his Bitcoin stored on it, worth $127 million at the time. However, he was not the only one who was victim of the usability of those systems. For example, other people simply forgot to store their private key and seed phrase, which also led to high monetary losses for them. Such news of usability issues of cryptocurrencies, as well as the tremendous rise of Bitcoin and Ethereum over the last years, made us wonder how people perceive such complex distributed systems. Therefore, the following 3 research questions emerged. First, what mental models of cryptocurrency systems and their functional components do users have? The second one is, which mental models interfere with the secure and privacy-preserving usage of cryptocurrency systems? And last but not least, how can cryptocurrency tools prevent security and privacy threats caused by user mental models? In order to answer those questions, we conducted a qualitative user study. The recruiting phase consisted of a short description of our study without revealing the concrete purpose of it to prevent any bias. Furthermore, we distributed a pre-selection questionnaire which asked demographics and a self-assessment of IT and cryptocurrency knowledge. Based on the answers the participants gave, we selected a sample fitting our recruitment criteria. The participants included were, on the one hand, active cryptocurrency users, and on the other hand, people who were not using cryptocurrencies, but worked with them in their professional life. In order to test the expressiveness and practicability of our interview guidelines, we conducted 3 pilot studies. We only changed the guidelines once after the first study. To be concrete, we decided to include buzzwords in order to make the answers more comparable. As no further changes were conducted for the remaining 2 interviews, we decided to include them in our final sample. Altogether, we therefore ended up with 29 participants. The study consisted of semi-structured questions, including 2 drawing tasks and 1 card assignment task. During the whole interview procedure, we asked the participants to verbalize their thoughts. Our final sample consisted of 1/3 female and 2/3 male participants. Furthermore, nearly half of the participants had a master's degree and a bit over a third had a bachelor degree. The remaining 17% finished high school as their highest completed education. The age of our participants varied between 18 and 42 years. I will now go on and show you an example interview based on study participant 8 to explain our study procedure in more detail. The first task was to draw with a black pencil all components and actors of the cryptocurrency system which the participant could think about, and also how those components and actors interact with each other. Hereby, we specifically asked about the buzzwords blockchain, decentralized system, and miners if the participant had not drawn or mentioned them during the interview. Afterwards, we gave the participant several cards with functions written on them, as for example, generate private key, generate transaction, or perform proof of work. We asked them to assign those cards to the drawn system from the first task. In this example, you see that the participant assigned all but 3 cards. Those 3 cards lie on the upper right corner of this picture. The participant expressed a lack of knowledge in respect to those 3 cards and was uncertain about the meaning of the expression broadcast transaction. The aim of the second drawing task was to highlight possible security and privacy risks within the system. In this picture, you can see the security risks drawn in red and the privacy risks drawn in blue. Furthermore, the participant was allowed to extend the system from the first drawing task with components and actors or other things he or she could think about with a green pencil. The methodological approach we used for our user study was grounded theory. This is an iterative process of data collection and analysis, which is repeated until theoretical saturation is reached. After the first 18 interviews of active cryptocurrency users, 2 researchers conducted an initial open coding process. Hereby, they generated preliminary categories based on recurring statements and assertions relating to the same phenomena. Based on those results, we decided to include people who do not actively use Bitcoin or Ethereum, but instead work in a field related to cryptocurrencies in order to get new insights. We assumed that those people are not influenced by any interfaces of exchange platforms or wallets, but instead have just theoretical knowledge about the system. After the second round of interviews, 3 researchers performed another round of open coding to refine the codes from the first round. Hereby, they used affinity mapping by cutting the transcripts into snippets and labeling them with sticky notes. This process you can see on those 2 pictures. Based on the contextualized statements of the coding process, we formed a so-called codebook. Our codebook consists of 4 top-level categories. The first category is the so-called meta category. It includes statements that are meaningful for building our theory, but are not directly related to the cryptocurrency and its functionality. It comprises interface biases, prerequisites, opinion changes of the participants throughout the interview, and statements about control and power, as well as some misconceptions about encryption and hashing. The second category is called system. It includes all statements about the blockchain itself, its storage and structure, as well as its behavior and its functionality. The last 2 categories you can see on the right-hand side, and they are called privacy and security. Those categories include all attacks and possible prevention mechanisms specific to the user's privacy and security. Before conducting the user study, we constructed an expert model of the transaction process in order to get appraisal factors for the user mental models. We do not claim exhaustiveness of our expert mental model, which can be incomplete and diverse as well. To increase the validity, we interviewed 2 experts and constructed 1 mental model incorporating the statements of both interviews. The system here, as you can see, consists of multiple participants, so-called peers. We grouped them into 4 different rules: a sender, a receiver, several miners, and other nodes. In this mental model, the sender is the person on the left-hand side, labeled as user. This user wants to transfer money to the receiver, who is the person on the opposite side, labeled Alice. The miners are in between and responsible for computing the next block with the transaction in it. The other nodes in the system do not participate directly in the transaction. However, they are still part of the system, as they can carry out their own transaction in parallel to the user's transaction, as well as validate the other ones. Please note that the comparison of users and expert mental models in our paper is purely illustrative and non-judgmental. Based on our codebook and the assigned codes, we generated 2 generic mental models. The first one is the so-called incomplete mental model. It represents only parts of the system, with some parts missing. We did not encounter poor decision-making as a result out of the incomplete mental model. Hence, the missing details are not crucial for a secure usage of the cryptocurrency system. On the other hand, here you can see the incorrect mental model of the system. It summarizes all misconceptions which can influence the user's security or privacy. In this model, for example, you can see that people considered some form of central entity as part of the system, whereby a single point of failure is assumed. Furthermore, a participant is considered either a central unit, the blockchain, or cloud is responsible for generating the keys and storing them. Altogether, we revealed major misconceptions related to 3 main topics. Those 3 topics we are going to discuss now in more detail. The first topic is cryptographic keys. Many users frequently do not understand the purpose of private keys, where they are generated, and also how important it is to keep them secure and private. The loss or the exposure of private keys leads directly to monetary losses. Participant 19, for example, stated, "I don't generate my private keys myself. They are saved in my smartphone app. It is generally the blockchain who generates it for me, or the network, the blockchain." Another false assumption was the anonymity and non-persistency of the system, which jeopardizes the privacy of people as they refrain from taking privacy measures. Participant 8, for example, stated, "After 8 blocks, one blockchain is ready, and it becomes one instance. Then the old one is deleted." Furthermore, many users did not know that by changing the amount of their fees, they can actively select how quickly their transaction will be included in the blockchain. Some participants thought that the transaction fees are fixed. Others thought that the miners calculate them depending on the importance of the transaction. Participant 20, for example, said, "Miners asked for transaction fees. I don't know if I can choose the amount. I'm in a hurry, and the miner adds an exorbitant amount of transaction fees." The cryptocurrency tools currently do not or not fully compensate all those misconceptions, which we show by evaluating the features of 4 popular software wallets at the time of our study. Therefore, we propose the following enhancements. In order to ensure that users do not lose their private key, a forced backup of the seed phrase and/or automatic key recovery should be provided by the wallets. Furthermore, as people thought that transactions are deleted after some time, or were not sure when their transaction is integrated in the blockchain, a visual block explorer could be provided. The purpose of fees and its influence on the transaction speed should be shown to the user by pre-computing options with labels on them stating, for example, fast transaction, medium transaction, or slow transaction. A wallet that already provides this enhancement, for example, is Koinomi. For further details of our study and the suggested enhancements, please have a look at our paper. With our work, we lay the basis for more user-friendly cryptocurrency management tools, which hopefully prevent accidents as throwing away millions of dollars in Bitcoin. I'm now at the end of this presentation and want to thank you for your attention. If there are any questions remaining, I want to invite you to my talk and the following Q&A session.